If the steam catapult represents the limits of the old industrial era, then the electromagnetic catapult is pulling the war directly into the electrification era. Now, the electromagnetic catapult has been officially installed on the aircraft carrier, no longer relying on boilers and high-pressure steam, but using a strong magnetic field to instantly accelerate the carrier-based aircraft weighing tens of tons to takeoff speed. Energy utilization efficiency is higher, and maintenance costs are lower. More importantly, CCTV recently exposed an electromagnetic catapult vehicle, which is significantly smaller in size and can be deployed modularly, like a heavy truck. This shows that power and control systems are being rapidly miniaturized, and electromagnetic launch is no longer just a Big Mac project. This raises a bold question. Can the same principle be installed on tanks, or even moved to the space battlefield? From a performance point of view, the electromagnetic gun is indeed very attractive. The experimental set of electromagnetic gun shells can reach an initial speed of more than Mach 6 in pure kinetic. Energy strikes can penetrate about 80 milliliters of military steel armor. Without gunpowder combustion, the sitting force is more controllable. Theoretical range and accuracy far exceed that of traditional tank guns. If the energy storage system in the future continues to compress the volume, the tank can even reduce the carrying of chemical munitions, and the concealment and continuous combat ability will be significantly improved. Of course, there are still practical bottlenecks. Timely power supply and radiator life are all engineering problems. But the emergence of electromagnetic catapult vehicles has shown that these problems are gradually being